Hey everyone, welcome to Code Harmony. Today we are going to solve this question 1462 core schedule 4. This question has been asked in Microsoft and Google, and it is based out of graph theory. And in this problem we will be understanding a very good graph theory concept, which is Floyd Warshall algorithm. This algorithm is usually used to find all pair shortest paths. Firstly, let's have a look on the problem statement. What is given to us here? Number of courses. They are saying that we are having a number of courses and labeled from 0 to number of courses minus 1, and you are also given a prerequisites entry will look like this: A, B. It is showing that course A is a prerequisite of course B. This is an example which is also given. Let's say this is a prerequisite entry 0, 1. It means that you have to take course 0 before you want to take course 1. Course 0 is a prerequisite of course 1. And they are also saying that this property is transitive. Let's say if A is a prerequisite of B and B is a prerequisite of C, it means then A is a prerequisite of C. And what we have to do? Apart from these two variables, the queries are also given. Queries will look like this: U to V, and we have to tell whether the U is a prerequisite of V or not. Yes or no. This Boolean answer for every query. If we are having m number of queries, m number of Boolean values we have to return in the answer array. So this is our problem statement. Now I will help you understand in a better way. First of all, we are given number of courses. Number of courses are 3, and it is labeled from 0 to n minus 1. So how many courses we are having? We are having these 3 courses. Courses label 0, label 1, label 2. And apart from this, we are having a prerequisites 2D array where every entry, let's say this is the first entry. First entry is going from 1 to 2. It is showing that 1 is a prerequisite of 2. It is in this order. Okay, if you want to take 2, yeah, you definitely have to take 1. You can only take courses in this order. 1 is a prerequisite of 2, and the second one is 1 is a prerequisite of 0 as well. Okay, like this. And 2 is a prerequisite of 0, like this. So if I try to draw this graph, it will look like this. So 1 is a prerequisite of 2. I'm trying to draw the graph in terms of path from prerequisite to the other nodes. So from 1 to 2, 1 is a prerequisite of 2, and 1 is also a prerequisite of 0. So it will look like this: 1 is also a prerequisite of 0, and 2 is a prerequisite of 0. From 2, if you should have taken 2 if you want to take 0. Okay, so the graph will look something like this. Let me just delete this type. Okay, this is our graph, and what we have to tell as the answer, we are having m number of queries. Query 1, query 2. Query 1 is something whether 1 is a prerequisite of 0. 1 is definitely prerequisite of 0 because a path is going in this direction. This 1 is a prerequisite of 0. We have drawn the graph in the way. Or you can directly say that 1, 0 is already given in the prerequisite array. So yeah, it is a prerequisite. And 1, 2, 1 is a prerequisite of 2. It's already given in the given input array. Okay, so for query 1, answer is true. Query 2, answer is also true. So this is our problem statement, that all the prerequisite entries are given to us, and we have to return whether the query is fulfilled or not. Query is something U to V, whether the U is a prerequisite of V or not. Let's say there is one more entry called 3. In this case, 1 is a prerequisite of 2, 2 is a prerequisite of 3, and 2 is a prerequisite of 0, 1 is a prerequisite of 0. In this problem, if I ask you, what is the answer of this query? Query is from 1 to 3, whether 1 is a prerequisite of 3 or not. You can directly tell me 1 is a prerequisite of 2 and 2 is a prerequisite of 3. It means that 1 is also a prerequisite of 3. So yes. Answer is yes for this query. Okay. And why the answer is yes? Because there is a path from prerequisite entry to the node. For every node from 3, for 3 prerequisite is 2, for 2 prerequisite is 1. Okay, so on this path I'm maintaining in this way that I'm firstly taking the prerequisite entry and then all the dependent entry. So this is my complete problem statement, and now let me know how you can approach this problem. First of all, let me give you one example where the problem will look like this. 1 is a prerequisite of 2 and 2 is a prerequisite of 3 and 3 is a prerequisite of 1. In this case there is a cycle. So how do we figure out? Just look at the constraint. In the constraint we are given that in the graph there is no cycle. Okay, and all the pairs are unique, so we don't have to worry about those things. And now from this we got the idea that we are going to draw a path from prerequisites to the dependencies. Now come to this example. Let's have a look in this example. Here 1 is a prerequisite of 2 and 2 is a prerequisite of 3 and 3 is a prerequisite of 4. Okay, so if I ask you that whether 1 is a prerequisite of 3 or not, 1, 3, you can directly tell me yes. Why? Because there is a path from 1 to 3. Okay, whether 1 is a prerequisite of 4 or not, 1 is a prerequisite of 4 or not. From 1 there is no path to 4, so this is a false. Okay, it means what I'm getting is I'm getting the idea that if there is a path, we are drawing path in such a way from prerequisite to the dependencies. If there is a path, it means that we are able to find whether this query is yes or not. Query's first value is u or second value is v, whether u is a prerequisite of v or not. Okay, so in this case if I just break it, it will break down to these two paths. Only these two paths we are having in this graph, 1, 2, 3, 4, 3, and from these two graphs we can say that 1 is a prerequisite of 2, 2 is a prerequisite of 3, or 1 is a prerequisite of 3 as well. Here 4 is a prerequisite of 3. Okay, these are the paths. So from this what idea I'm getting is, this is the idea that I am getting. Just try to read this statement. For every starting node u, for every u to v query, for every u is a prerequisite of all the nodes on its path. Okay, so u is a prerequisite. Let's say u is 2. U is a prerequisite of all the nodes on its path. 2 has a path going in this direction. 1 is not on its path, so 2 is a prerequisite of 3. If 1 is u, then this is the path 2 and 3. U is a prerequisite of 2 and 3, or in short 1 is a prerequisite of 2 and 3. So this is something that we have to figure out. Okay, so the problem statement given to us is number of courses, a prerequisite array, a query. For every query u to v, whether the query is yes or no, u is a prerequisite or not, we can directly say if we have the path. If we have the path, let's say in this case from u to v, if v is on the path from u, then u is a prerequisite of it. So this is something that we have to do. Okay, and now there is two ways we are coming to the approaches. The first approach is topological sorting. But we have to use the topological sorting in such a way that from every node we have to capture what are the dependencies coming on its path. Okay, because ultimately we require paths, this path and this path. If we do the topological sorting from 1 is a prerequisite of 2, 2 is a prerequisite of 3. Just capture the path when we do the topological sorting, and you can do it in a BFS way or DFS way. It's totally up to you. Keep track of the paths. But I'm trying to say is, using topological sorting, we are able to figure out the path. If we have the paths, we can directly tell whether the query result is true or false. And what is the second approach? Second approach is something we are definitely going to focus in this problem. Second approach is all pair shortest path. All pair shortest path. Our query will look like this. Queries will look like this from U to V. This is our query. Our query is going to be something like this from U to V, whether the U is a prerequisite of V or not. And this can be of any path. And let's say you have some kind of magical approach. That approach is going to give you all pair shortest path. It means all pair shortest path means from U to V, the shortest path. What is the length of the shortest path or something like this? Let's say graph is something like this: 1, 2, 3. 1 is a prerequisite of 2, 2 is a prerequisite of 3, and query is something 1, 3. Whether 1 is a prerequisite of 3 or not. It means if I have the all pair shortest path, it means from 1 to 3 the shortest path is of size 2. It means if the shortest path exists, it means we can say that there is a path. If there is a path, 1 is a prerequisite. If there is no path, let's say infinity is there. If no path, no prerequisite, query result is false. Now query result is true. So in this case, if somehow we are able to get all pair path, we will be able to answer our query. Our query is something from U to V, whether there is a edge or not. If there is a path starting from U and going till V. Starting from U and going till V, if this path is there, we can directly tell whether this query is true or false. So what about the shortest? Ignore this shortest. We are not bothered about the shortest or all pair path. All pair path, just a subset of this problem. All pair path. Shortest is not required. It means shortest means value of the path. Whether path is of size 2, size 3. What we require? We just require whether there is a path or not. Yes or no. Whether there is a path from U to V or not. So instead of storing the values, we can just have Boolean value. All pair, not shortest, just path. All pair path from U to V is going to have a value. So ignore the value, ignore the shortest, just take a Boolean value. Whether there is a path from U to V. And see, this to find all pair shortest path, there is one algorithm, Floyd Warshall algorithm. So this algorithm is going to give us all pair shortest path using dynamic programming approach. All pair shortest path from 1 to 2. See, what we usually do in this algorithm is from 1 to 3, the path is already given because 1 is a prerequisite of 3. Okay, the path is given, but there might be chances because our property is transitive. So if 1 is dependent, 1 is a prerequisite of 2 and 2 is a prerequisite of 3, then also 1 is a prerequisite of 3. It means either there can be direct path or indirect path via some other edge or via some other course. So there can be chances that 1 is a prerequisite of 0 or 0 is a prerequisite of 3. So in this case, there is a path. So if it is a direct path, yes. If it is an indirect path from some other course node, then also it is a yes. Okay. So this is our Floyd Warshall algorithm and all pair shortest path. If I just copy the pairs 1 to 1 0 2 0, 1 to 1 0 2 0, it means from 1 to 2 there is a path. From 1 to 2, yes, there is a path. From 1 to 0, 1 to 0, there is a path. From 2 to 0, there is a path. 2 to 0, there is a path. If I just draw it again, 1 to 2, 1 to 0 and 2 to 0. Now if I just ask you a question that from 1 to 0 there is a path, 1 to 2 there is a path, 2 to 0 there is a path. Let's take one more example. 2 to 3. If 2 to 3, there is a path 2 to 3 and 2, 3. 2 and 3, this will also be yes. Okay. Now I want you to give me the answer of 1, 3. If you want to give me the 1, 3 answer, the 1, 3 is not yet set. Okay. But this value is initialized with the prerequisite array already given to us. It means there might be other paths from different nodes. From 1 to 3, there might be other path via 2 or via 0. Okay. Via 0 there is no path, and via 2, from 1 to 2, via 2. How do we figure out the path there is from 2? Whether there is a path from 1 to 2 and 2 to 3. From 1 to 2, yes, there is a path. From 2 to 3, there is a path. So it means from 1 to 3, there will always be a path. Okay. So this is kind of approach we use. Here, what is our understanding? That for every u to v, either there is a direct path or path via some other node vertex, which is k. So from u to v, firstly, prerequisite is given to us. Prerequisite is given to us for I equal to 0, I less than n, I plus plus. For j equal to 0, j less than n, j plus plus. If it is n cross n, yeah. N is our size of courses. Courses will go from 0 to n minus 1. So this is the loop. And whether there is a prerequisite from u to v, which is I to j. Whether there is a prerequisite from I to j is equal to, see, I am trying to build the approach. For every combination we have to try, we need to know whether there is a path from I to j. There are two possibilities. Either there is a direct path. It means prerequisite of I and j. If there is a direct path, or if not direct, then path via some other vertex. So prerequisite of from I to k and prerequisite of k to j. If that is the path, like this. From 1 to 3, this is the direct path, or this might be some other vertex. This might be some other vertex. This is the other vertex, which is k. So this is our algorithm. For every possibility, I'm going to capture the path from I to j. And now what is the value of k? What is the value of k? Value of k will also go from 0 to n minus 1. So the whole scenario we can do for I equal to 0, I less than n, I plus plus. This is not I, this is k. K equal to 0 and k plus plus. For every k going from 0 to n minus 1, if you use this formula, and this is our main formula, whether there is a direct path, this is our main formula, whether there is a direct path or path via some other vertex. Okay. Loop of size n, loop of size n, and this k is also of size n. So time complexity will go around n cube. So this is our Floyd Warshall algorithm. Floyd Warshall algorithm, where we have modified not to find the shortest path, but just to find the path. Now we will have a look on the code. Here what I have done is I have taken a boolean 2D matrix is prerequisite, whether u is a prerequisite of v or not. So prerequisites are also given. So these prerequisites I have added in the is prerequisite matrix. And after that I have used my formula directly. I want to know whether I is a prerequisite of j, and we are going to calculate it for all the pairs. If all the pairs, we will be able to answer every query in a constant time if we know the answer of that query. So for I to j is prerequisite. There is one possibility, there is a direct path from I to j, or there is a path through any intermediate node, which is k. there is a path from I to K and K to J. If this is the case or this is the case, then we are storing the value for it, and we only require whether there is a path or not, yes or no. So all possible pairs. And after that I have the answer, and whatever the query is from I and J, and whatever is the query, I just return the answer, whether it's a Boolean or false or true in my 2D matrix or not. So this is the only main statement at line number 12. This is the formula that we discussed, and it's a order of n cube time. And let me see if it's running fine or not. Sample tasks are working fine. I'm submitting the problem. It's submitted successfully. I hope you have understood the approach. It's Floyd Warshall algorithm, and it's very good concept of graph theory. And if you have any doubt, you can comment down below. I will try to address your questions. Bye bye guys. Thank you.